In this video, we would like to talk about the price elasticity of population and how it fits into the Simon abundance framework. So let's begin recalling that the price elasticity of population is equal to the percentage change in time price divided by the percentage change in population. So if we graph this, we see, let's put percentage change of population on the horizontal axis and the percentage change in time prices on the vertical axis. And let's just set the percentage change in population from 0 to 100%. We always assume, once again, that population is going to be increasing. On the percentage change in time prices, we will set our axis there at 0, from 0 up to 100% and down to a minus 100%. So we begin initially by drawing our first line, and that's a 45-degree line. When prices are increasing and population is increasing, we call that the sustaining line, and that's when the price elasticity of population is equal to 1. So the area above that 45-degree line is the case where prices are actually increasing faster than population. We define that zone as the decreasing abundance zone. The area below that occurs when prices are increasing, but population is increasing at a faster rate. We define that zone as the emerging abundant zone. So when prices are not changing as population is increasing, we demarcate that line with what we call the inversion line. In that case, our price elasticity of population equation is going to be equal to 0. Below that line is the area where prices are actually decreasing while population is increasing. We actually have two zones in that area that are of interest. The first zone, that area below is divided by what we call the Nirvana Line, and this is the equation for that line. The Nirvana Line essentially is a situation where prices are decreasing proportionately faster than population is increasing. The area above that Nirvana line we call the accelerating abundance zone, and the area below that we call the superabundant zone. Let's take a look at how this would work with an example. So let's assume that population increased 70%. So we would draw our change in population line at 70%. And let's just see how this equation works as we begin to look at different changes in prices. So remember, the equation is the percentage change in time price over the percentage change in population. So our denominator in this case would be 70%. So let's assume we were at this location where prices were actually increasing at 80%. Our equation would be 80% over 70%. Or the PEP in this case would be 1.14. We would be experiencing decreasing abundance. So let's look at the next location where the prices were increasing at exactly 70%. With the change in population at 70%, our equation would yield a PEP value of 1.0. If we were to observe a situation where prices were increasing but at less than 70%, our PEP would then drop below 1, and this would be in our emerging abundance zone. So anything above 1.0 would be decreasing abundance. Anything below 1.1 and above 0 would be emerging abundance. So if we observed a situation where prices were not changing while population was increasing, we would be right on the inversion line. Our PEP in that case would be equal to 0. Now, if we were to observe prices actually decreasing as population was increasing, we would note that our PEP would actually be negative. In this case, if prices were increasing or decreasing at 20%, we would notice that our PEP would be a minus 0.28. That would be, we would interpret that as abundance accelerating. If prices were increasing proportionally at the rate necessary in order for our increases in population to be exactly offset by the decrease in time prices, we would be right on that Nirvana line. And in that case, we calculate that rate to be a minus 41%. That would give us a PEP of 0.59. In this case, we would be observing that as we increase population, our actual cost or our total cost would not change. Now, if we were to drop below this and prices were decreasing, let's say at 70%, while population was increasing at 70%, our equation would be a minus 1.0. We would actually be enjoying superabundance, where time prices are actually decreasing at a faster rate proportionally than population is increasing. So that is our framework that we use to interpret the price elasticity of population. Once again, there are three lines: the sustaining line, the inversion line, and the Nirvana line. And they divide our areas up into four zones: the decreasing abundance zone, the emerging abundance zone, the accelerating abundance zone, and the superabundance zone. Thank you for watching this video.